All right, next up, we have Tom Howlett and Prasenjit Sakar from Sonar. They're going to tackle a question every engineering leader here is probably thinking about right now. Can LLMs actually generate enterprise quality code? Not just faster code, but reliable, maintainable, and securable code. So welcome, Tom and Prasenjit. I'll turn it over to you.
Thank you. Cheers. Okay, so we're going to jump from leadership to relatively technical, I guess. It's going to be a bit of a shift. Clicker. Perfect. Okay, so I'm Tom Howlett. I'm in product management at Sonar. You probably know us from SonarCube, maybe.
And myself is Prasenjit Sarkar. I'm the technical product marketing manager at Sonar.
Cool. And today we're going to talk about creating enterprise quality code with LLMs. Right. So as I'm sure you're aware, AI is writing in explosive volumes of code. That's generating explosive volumes of excitement, of fear, as I talk to a lot of the CTOs here, and a lot of questions, a lot of really open questions. So the big question we're going to try answer today is AI code ready for the enterprise? I think we know that the code is very capable, that it's functional, that we know it can do some incredible things, but is it secure? Is it reliable? Is it maintainable? Is it all the things we need in the enterprise to be able to be used effectively? And can we gain from those productivity improvements that we see? So let's start with an LLM out of the box. We'll move on to kind of what else we'll need later. But the first thing we wanted to know at Sonar was, out of the box, is the code good enough? And so the way most people look at this is benchmarks, right? We've all seen the LLM benchmarks. Every time a new LLM comes out, people look at the benchmarks. Oh, excitement, we're another 0.3% up on some functional criteria. Does that help us in the enterprise? I'm not sure. So what the enterprise don't tell us is, again, how maintainable will that code be in the future, right? And again, is it secure? Is it reliable, etc.? So, but yeah, what can we do about it, Prasenjit?
So to tackle that challenge, we have created a kind of a benchmark, and we have created a kind of a framework that actually analyzes the code which is being generated by the LLM as well. So we just don't go by the numbers that they're publishing. So what we have done is we have taken all the top leaders in the LLM, and we ran that through our own benchmark or our own evaluation framework. To do that, what we have done is, as you can see, that we have taken up the top models. We have gone it through the open source 4,444 Java programming assignments, and then we ran it through the results. And the results were evaluated by the SonarCube Enterprise. And you will see that there are many challenges that we found out. But the inherent question is that why the problems are there. So the problems why the codes are not so maintainable, or the codes are not bug-free, the code is not perfect, is because of what the code is being trained on. So there are mixed amount of code. The LLM is getting trained, some of the good code, some of the bad code. So there is a mix of code that is being trained on, right? So there's a mix of quality. So that's one of the major challenge. The second problem is the codes also are having the security flaws. So the LLM is learning from that as well. And obviously there are hidden bugs, right? So those are the major things that we found out from our evaluation framework. And obviously the nature of the LLMs itself, because they are not deterministic, they are probabilistic, right? So it runs on the probability factor. So that's the first factor. The second factor is those code which is being generated right now from your prompt does not have the context what your quality standard looks like, right? So that's one of the other missing points, and it is hard to diagnose, hard to explainable, because the amount of code that is being generated for a single assignment is enormous, and I'm going to show you the number. So for that, we created the Sonar LLM leaderboard. So this LLM leaderboard is open for everybody. It's Sonar, sonar.com/leaderboard. You can go and see this leaderboard. And we have evaluated across 50 plus models so far. There are open weights model, there are foundation model as well. As you can see that rightly, all the LLM leaders are right there. Opus 4.5, 4.6, Gemini, GPT 4.5.4 Pro as well. So we have evaluated all of them. And the result is astonishing. So we have top 5 models by the pass rate. This is not the number that I'm publishing. This is the number which the companies are publishing. But if you look at the number in here, and you'll see that obviously their pass rate. There are 10 plus models which have crossed the 80% limit. But if you look at the issues density across all of them, I'm showing you only 5 of them in here because I don't have space. But if you look at the issue density, there are across like 20, between like 15 to 20. Not too bad, but this is again the number of issues per 1,000 lines of code that you are generating, right? Per 1,000 lines of code, you are getting 15 to 20 different issues. We can see that Opus 4.5 is the highest one, the highest rating right now, with a relatively low issue rate. So next one is the complexity. So there are 2 different things in the complexity side. One is the cyclomatic complexity, and one is the cognitive complexity. Cyclomatic complexity is where you're going to see that how many ifs and else if and for loop and all the other control statements that are there. The more number of control statements means the more problem that you have in terms of analyzing the code, running the test, what kind of test you are going to run. That's one of the complexity. The second of the complexity is the cognitive complexity, which is made by Sonar. And that is like how complex the code is, which is being generated by the LLM itself, by a human being, right? If you want to read that code, if you want to analyze that code, if you want to fix any bug, how about that complexity? So if I show you the number here, this is the number that is being generated from our analysis. So we found out that GPT 5.2 High is writing around 1 million line of code for only those 4,444 Java assignments. 1 million line of code, right? And you can see the kind of complexity. So the more models, the more newer LLM models that are coming up, they are more verbose. So the other day we have analyzed and updated our leaderboard showing that GPT 5.4 Pro or GPT 5.4 in medium and high and extra high, X-high reasoning effort, they are generating 1.2 million line of code for those 4.4 K Java assignments. That's just about 4.4 K Java assignments. There are different code languages, there are different frameworks as well, right? So you can see the number of verbosity. And then the newer models are actually just not creating the verbose code, but they are also generating enormous number of bugs. So code maintainability, code smell, different type of security vulnerabilities. So there are many vulnerabilities that we are seeing that these models are generating. So newer models does not mean that they are giving you the perfect code that you are looking for. So what we are saying is that you need to look at these numbers and see that what exactly you are getting on. So you write the code, but you need to verify this as well. So here is the point that the number of vulnerabilities that we have seen across GPT 4.0 and let's say 4.5 thinking, 4.5, 6 thinking from the Opus is around 150, 120, 150. So per million lines of code, we have 150 bugs, 150 security vulnerabilities. Those are blocker security vulnerabilities, right? This is really, really a great eye-opener for everyone. When we started evaluating this, from our perspective, we were blown away looking at this number. But these are the facts. I mean, we just ran through this stuff. And at the same time, you have the bugs per model as well. So these are critical bugs that are, what we have seen is that the models which are coming up in the newer side, they are creating more fascinated bugs. So not those bugs that you have ever seen. There are new control statements. There are new bugs that we have seen there getting introduced in the newer models. So you have seen this problem that is there. So LLMs are not perfect. They are generating code. They are doing all of the good stuff, but you need to verify as well. So these are the problems. But Tom, remind me, what exactly are we doing to fix this problem?
Well, we could do what SonyCube always does, which is catch all these issues in the quality gate and then ask the developer to go back and fix them. But that's not going to prove very popular, and it's certainly going to slow down all of the productivity improvements we've seen. So we're thinking about, well, how do we improve that? Well, if you have a new developer come into your organization, you don't just sit them down in front of a computer, give them access to all your repos, ask them to code away, well, hopefully you don't, and then let them commit the code, right? You first need to help them understand, okay, what are we trying to achieve? What are the abstractions in the code at the moment? How is it represented? How is it architected? What are the standards you have in your organization for writing code? Yet when we do these benchmarks, we're basically just sitting them down with no context. So what we've been kind of working on is making sure that the agent has access to all of these things it needs to write the enterprise level code in the first place. And we're kind of calling that ACDC, which seems slightly catchy, the agentic-centric development cycle. Now, there's still a human-centric one that wraps around this, but what we want to get from ACDC is that the agent is able to generate that good quality code in the first place without having to go back and the developer tell it to fix things later. So, our agentic ecosystem as it currently stands. The first thing is actually giving it the context it needs. Now, I'm sure you've all kind of heard of context windows. If you throw tons of stuff in your context window, it doesn't necessarily help the agent at all. The agent gets confused. It doesn't necessarily interpret it pretty well. So what we're focusing on is for whatever task the agent is working on, to give it the right context, give it the context it needs to do that well. The two areas we're focusing on at the moment is one, kind of coding guidelines. So if it's about to make a change to a data access component, what are the guidelines? What are the rules that we have in our organization around creating data access components that it should follow? And we look at that. We look at past issues when people have written data access components, bring those back and tell the agent, okay, avoid breaking these rules before you start. And that in itself has a great impact. The other thing we do is give it architectural context. So if you haven't been on SonyCube in the last few days, you may not have seen our new architecture feature. So now within SonyCube, you can define your desired architecture. You can set out your models. You can say every controller can only access a server, which can access the data layer, etc. You can break that right down. You can get as fine-grained as you like, and you can create a model. And SonyCube will then tell you if you're creating code which breaks your model effectively, if you've got architectural sprawl. So we're already giving that to the agent. And that makes a real difference. It doesn't just make a difference in the quality of the code and the number of issues it creates, but actually it works a lot faster because it's not having to dig through all of the code to try to understand the desired architecture in the code. It can just get it straight from an MCP, get it from the agent. Okay, this is what the architecture should look like. In the area I'm in at the moment, these are the specific bits. So we give it the specific architectural information it needs to carry out that task. And that not only kind of gives us better quality, but also helps the agent run with less tokens much faster because it's just working less hard to try to discover this information itself from the code base. And I think there's a lot more we'll do around context. So once we've helped the agent generate the code, we then want to go through what our junior developer would have done with the code review process. Now, our goal is to get the code as clean as it possibly can be before it's presented back to the human. So we've been developing a new service which allows the agent to do a very deep analysis. So this isn't just like a linter that you might have in an IDE. This is doing a full analysis that you would normally only get in the CI in an analyzer. But we're finding ways to do this using kind of previous context from previous analysis to do that in 1 or 2 seconds. So the agent can just do it. Every time it writes a file, it can go and get an analysis, make sure it's not creating any issues. And obviously, we all know the earlier you identify and fix issues, the faster your development process goes. So we're kind of moving the sort of agile CI process to an even faster cycle within the agent iteration loops. And yeah, we're seeing some good results from that. So when the agent finally comes back with a whole load of code, and it really is a whole load of code now, right? We're not just talking about Copilot completing things. We're talking about Claude having completed a task and written maybe 1,000 lines of code, quite feasible, maybe more. It does still need to be reviewed. The agent isn't accountable for the quality of the code. You're not going to fire it if it makes a mistake. So somebody needs to be accountable. Somebody needs to understand what's been written. And I spoke to a few CTOs yesterday, and one thing that keeps coming up is a fear of developers rubber stamping a change, a code, and not being able to go through it. And it's really hard, right? I think the stats kind of show if you've got a change over 400 lines of code, the chances that you really kind of review it properly are very slim, right? You tend to do the same amount of time reviewing 1,000 lines of code as you do 400 lines of code. You just don't do it as well, right? So there's a lot of code review tools coming onto the market, and we're building our own as well, which basically break down this change into smaller parts that can be understood and can be kind of reviewed separately and given that context as well. So the reviewer needs the same context, right? This is following this pattern, this is doing this, and then you can really verify it. So I think the code review side of it is, we haven't got the tools at the moment for these types of changes, and I think there's a real rush to develop that, of which we're doing it. So once you finally kind of get through and you've committed the code, you've probably still got a whole bunch of issues on your code base. Luckily, agents are now getting really good at fixing those issues. So we're building remediation agents that can go through your issue backlog and start breaking them down. But then you can also give that task to agents as well to do that work. That works really well. So hopefully we're kind of starting to come together in this agentic-centric life cycle, which I think we're just starting to see now what development's going to look like moving forward in the enterprise, but hopefully this has given us a bit of a taste. So actions, what can we take away? So first thing, really understanding the limitations of your LLM now. Obviously, we can look at the benchmark. You can get into more details. You didn't really see it there, but you can actually see the types of issues that each LLM is creating. And each one is different. I'm always shocked. It's a different set of problems. It's a new set of things. They fix some issues and then something else emerges. The complexity increases, something else emerges. They're always different. You then think about what context are you going to give your agents, right? And there is your kind of fixed context that will be on your agent's MD. You might have skills and things like that you're using, which it can standardize the way it works in a good way. But also think about dynamic context as well. What context can you provide for a specific task that it's going? Because you don't want to fill your context window up with the whole company knowledge base. It's not going to help. Measure the impact of the changes you make. You hear a lot of stories about people having these huge Claude MDs and it just making their results worse, right? I think this stuff is not deterministic. It's not easy to see what the results will be. When there's an upgrade in model, the impact can change again. So you need to have some kind of way of evaluating the quality based on the process you currently have within your enterprise and based on the tools you're giving the agent. And then provide the agent with ability to verify and fix issues itself. Don't leave it to the developer. I guess this is obvious, right? Everyone kind of realizes we can't have developer fixing the problems the agents create. An efficient review process is going to be critical. I'm sure everyone's thinking about it already. We haven't got time to review in the same way. And finally, start thinking about the backlog of technical debt you had. We now have capabilities to start eating through that in a more economical way, whereas in the past, fixing old issues on repositories was generally nobody had time for it. So yeah, so that's it. Come and see us at the booth if you want to talk about this more. The things we've just shown with the context augmentation and the agent analysis is available in beta now, so I can set you up with that today if you want to try it. We'd love to hear what you think, love to hear what you're doing around this. It's obviously very new and emergent. There's so much hype around people in their bedrooms kind of building applications in minutes, but not around what's happening in the enterprise. I don't think people are talking about it enough, so we'd love to talk about this. Cool, we got questions.
Yeah, Yeah, I'll take the first question. Is it, sorry, yeah. Oh, okay, that is it relevant to compare the number of line of code that has not been reliably measured in software development in the past? Well, that's just one number. So the number of line of codes shows the verbosity, means the number of line of code that you're increasing. It means that, as Tom mentioned, that the review cycle gets more and more complex. And there are more and more chances that you're going to get bugs, security vulnerabilities, code smell, and all the other problems, right? If you look at the older models or the open weight models, those used to write, for example, we have, last year we have evaluated a model called OpenCoder. That has generated, like, I think, 50,000 line of code. But the 50,000 line of code and the million line of code, you can imagine the kind of verbosity that we are generating and the chances of getting those bugs. So yes, it is relevant, but it is not just the only number that we should rely on. We should rely on the other metrics as well.
Yeah, I think the lines of code is a fair measure of your maintainability costs, to be frank, right? You need to understand, if you're reading through those lines of code, it's a reasonable thing about maintainability cost. It doesn't say much about functionality.
What would be an average human pass rate in your leaderboard? That's so this is not something that we are measuring on. But if you look at this is coming from the models itself, or the companies who are making the foundation models. What we have seen so far last 6 months. All of the models that are coming up, including the open word model, for example, let's say from Z.AI, a couple of weeks back, we got a model called GLM5. That's the open word model. And even that open word model is crossing the 80% boundary. So looking at that, we could say that since last 10 to 12 models out of the 50 models have crossed the average of, let's say, 80% out of the 50 models that we have evaluated.
Is code maintainability still an issue if LLMs can consistently regenerate a working product from specifications? I mean, I think this is super interesting, right? If you've got the unit tests and you've got all of the other checks in place, yes, you can probably refactor your code more easily, but you need to have, like, I mean, just a prompt saying what to build isn't good enough, right? We need the very specific requirements. Those are probably encoded in tests in some ways. So I think this is a super interesting question that will start to emerge. We might not think about the maintainability of the actual code, but we still got to think about the specification and how complete that is. I mean, whenever I've done rewrites, there's always new issues emerge, right? So I'm sure that would be the same, unless you have a perfect specification, which nobody has. So,
and even for that matter, LLMs by nature is probabilistic. So today you generate something, and then tomorrow you just run the same prompt. You may not get the same code. You may not get the same exact line of code and the verbosity and the personality for that code as well. Okay, next question. Why do you want only benchmark Java? Well, that was a pretty good start for us. We are right now working on the other programming languages as well. And it is an open data set. We picked up an open source Java programming assignments. And it was readily available, so we picked up Java as to start with. But we are working on the other programming languages as well. Okay, next one.
I think we kind of answered that. It's gone. Hold on. Okay.
How does differ from just having all of this code base and pointing cloud at it? Example, architecture diagram and desired architecture.
So I mean, it's worth experimenting with giving an architectural diagram. I think what we're finding is giving it the specific context for the job that it's going to do is more effective than giving it something general. But that's not to say that you shouldn't give Claude that good, an architectural diagram as well, right? It could still be useful, but that could be huge, right, for your organization. So, I mean, we're absolutely not saying this is the only useful context, and there's still so much discovery still to do on context. So yeah, I would try different things and test the results. That's the key bit.
Are you testing the LLMs directly? The best results of coding are when the model runs in the harness. We have our own evaluation framework that we have developed. So we are using LLMs with our coding standard, and also at the same time we are we are using the APIs directly from the models or the companies that they are building it on. So we are not exactly using Claude or Codex or Gemini or Goose or any other stuff. But yeah, we are using our own framework to run it through to check what exactly are there. That's the best way to evaluate a framework, or I would say kind of a model. Tom, I think the next question for you.
The confidential bit. I thought you would do that. You're in marketing.
No, you are okay to take them. You're okay to take a picture of that. There are, so all the products that we have shared, these are all either on public, either public beta. So yeah, this is fine for you guys. Okay, probably last question. Do you see LLM producing vulnerability-free code in the near future? That's very hard to say. That's very, very hard to say. Because what we have seen, the trend is on the upper side, not on the lower side. So the more and more newer models are coming in, they are actually creating more and more security vulnerabilities, code smell, bugs, rather than compressing them. So somewhere they are learning from their previous mistakes, which is not generating the obvious bugs. So they are suppressing them. They are training that data on that same data, but they are creating some more fascinated bugs, fascinated security vulnerabilities. So the trend is actually opposite. I don't know whether it will be fair to say that there will be a completely bug-free or vulnerability-free LLMs.
I think even if they do, you're going to have no guarantee.
Yeah.
So you're going to have you need a way to verify it anyway, right? I'm sure they're going to get better at the issues they're currently creating. We still need to verify.
Cool. Thank you.
Thank you very much.